Here in this video, we are going to see a formula or an expression of slope and deflection for a given simply supported beam. So it is expression for slope and deflection for a given simply supported beam. So now here I am going to draw the diagram of a simply supported beam, and then we are going to find its slope and deflection. Here I am considering a simply supported beam which is carrying a point load W. Now here I am considering that the load is acting exactly at the center. If the length of the beam is capital L, then L by 2 distance from each of the supports, we are having the point load W. Now for such a beam, we need to find the slope and deflection equation. So here for this, I'll say that first of all, I'm going to find the reaction at A and reaction at B. That is the first step. So I'll say that since the given beam is symmetric, therefore, now the beam is symmetric because the load value is located at equal distance from both the supports. So therefore, the total load W will be shared equally by each of the supports. So therefore, the reaction will become reaction at A will be equal to reaction at B, and the load will be shared equally by them. That is, the total load is W. So W by 2 will be shared by reaction at A. It will share W by 2, and reaction at B, it will also share W by 2. Now, once we get the reactions, the next thing would be consider a section XX at a distance small x from left hand support, that is A. So from A, now I am going to consider a section, and that section should be such that it should be far away from A and close to point B, because we are going to use the double integration method here, also called as Macaulay's method. Now here I am taking the section XX and its distance is X from the left hand support. So now once I have taken the section, I'll say that taking moments at section XX, we get, now when we are taking the moments, here the consideration is clockwise moment positive and anti-clockwise moment negative. So when I am taking the moment at XX, that is moment at XX is equal to, it is given by EI d square y by dx square, and that will be equal to, now the first moment is of RA, it produces clockwise moment, so clockwise moment is positive, so this is RA into X. Next, W, it produces anti-clockwise moment and it is located at a distance of x minus L by 2 from distance x. As I can see here, the section is x, so the distance is between the load W and section xx, that is x minus L by 2. So it is minus W into x minus L by 2. Now, after reaching here, since we are going to use the Macaulay's method, or called as a double integration method, so I'll say that using Macaulay's method, integrating the above equation once we get. Now, this equation, I'll call it as equation 1, and this equation 1 we are going to integrate once, so we have EI as the constant, d square y by dx square, integration of this will be dy by dx is equal to RA, reaction at A, that is we have found out it is W by 2, integration of x, that becomes x square by 2 plus constant C1, this is the first term. Next, minus W will remain as it is, and here we have x minus L by 2, so integration of this term will be x minus L by 2 whole square divided by 2. So I will keep this as the second equation. Next, integrating once again, that is equation second. So now I am going to integrate the second equation, so we have EI will remain as it is, dy by dx integration is y, this is W by 2 into 2, that is 4, integration of x square is x cube by 3 plus C1, integration is with respect to dx, so it will be C1 into x. As I am integrating twice, so here first we have integrated once, now we are integrating once again, so integration of C1 into x, then plus C2, because we have integrated twice, so two constants. Next, minus W by 2 will remain as it is. Here we have x minus L by 2 whole cube, because the integration of x minus L by 2 whole square is x minus L by 2 whole cube, into 3 because it is divided by 3. Next, I'll simplify this. So therefore, EI into y will become W by 12 x cube plus C1x plus C2 minus W by 6 x minus L by 2 whole cube. So I will keep this as equation number 3. So now here I am getting another equation, which is equation 3. It is in the form of y, so called as deflection equation. Equation 2 was in the form of dy by dx, so slope equation. Now we need to know the values of constant C1 and C2. So for that, I'll say that in order to find constants C1 and C2, we need to apply boundary conditions. So therefore, the boundary conditions are at x is equal to 0. Here if we see in the diagram, when x is 0, the deflection y is 0. So at x is equal to 0, y is equal to 0. Next, at x is equal to capital L, that is up to point B, here also deflection is 0, y is 0. So we are going to put this boundary condition in equation 3. So first I'll say that put first boundary condition in equation 3. So we have at x is equal to 0, y is 0. So this left hand side becomes 0. X value, if we put 0, the first term is 0. Plus if we put x value here, that is 0 plus c2. The first boundary condition we have to put it only up to the constant c2. So therefore c2 becomes 0. Next, applying the second boundary condition, that is put second boundary condition in equation 3. Therefore we have in equation 3 the second boundary condition is at x is equal to L, y is 0. So if y is 0, left hand side becomes 0. Now wherever we see L, we have to replace it by x. Wherever here we are seeing x, it has to be replaced by L. So here we have w by 2, 12 as it is. Next, x cube will become L cube. So it is WL cube by 12 plus C1 into x. So it will become C1 into L plus C2 is 0. Then minus W by 6. Instead of x, I'll put L. So L minus L by 2 whole cube. Therefore, we have 0 is equal to WL cube by 12 plus C1 into L minus W by 6. Now this bracket, if I simplify, this becomes 2L minus L upon 2. So that becomes L by 2 and it is whole cube. So L by 2 whole cube will be L cube by 8. So this complete bracket, it can be simplified to L cube by 8. Now, therefore, here we have WL cube by 12 plus C1 into L minus WL cube by 6 into 8, that is 48. We want the value of C1, so I'll shift this term. So C1 into L becomes WL cube by 48. It is negative. When it goes on to the other side, it is positive. WL cube by 12 is positive. When it comes on the other side, becomes negative. So this will be 48. And here we have WL cube minus multiplied by 4 here to make it 48. 4 in the numerator. So therefore, we have C1 into L as this becomes minus 3 WL cube by 48. So L and L gets cancelled from both the sides. Here we have L square. So the value of C1 is, therefore C1 comes out to be minus 3 WL square by 48. And C2 value we have already found out, that is 0. Next, I'll say that therefore put C1 and C2 in equation second. So here we have EI, which is as it is, dy by dx as it is, it's equal to, now W by 4, I'll write it here, W by 4 because it is 2 into 2 and here it is x square. Then it was plus C1. C1 value is minus 3 WL square by 48. Then I'll copy the next term as it is. So minus W by 2 into x minus L by 2 whole square. So therefore I'll keep dy by dx on one side. EI is multiplied here. If I get it in the denominator here, it will be 1 upon EI. Now this equation which I have got, this will be equation number 4 for us. and I'll say that therefore equation 4 is called as slope equation, and using this equation we can find slope at any given point. Similarly, I'll say that therefore put C1 and C2 values in equation number 3. So after reaching up to the slope equation, I'll say that therefore put C1 and C2 in equation number 3. Previously we have put the values in equation second, so now I'm putting the values. Here we have in equation 3 ei into y is on one side, on the right hand side we have w by 12 x cube. Next it is plus c1 into x, c1 is minus 3 w L square by 48 into x. C2 plus C2 is 0, so we can neglect this term and copy the last term as it is. So therefore I'll keep y on one side. Here this will become 1 upon ei into the bracket w by 12 x cube minus 3 wl square by 48 into x minus w by 6 x minus L by 2 whole cube. So this is the other equation. This will be equation number 5. So therefore equation number 5 gives deflection equation, and with the help of that we can find deflection at any given point. Now after reaching here as we have seen, in equation 5 we get deflection equation, in equation 4 we were having slope equation. Now we will find slope and deflection at various points. So the first thing would be, I'll consider the beam which is given, that is simply supported beam, and I'll find the slope at point A. So I'll say that after this, now the first thing is calculation of slope at point A. Now at point A, when I am calculating the slope, I'll keep the distance x as 0. So here at x is equal to 0, so put this in equation 4, that is the slope equation, and here we have the slope equation. I'll put x is 0, so therefore we have dy by dx, this is at point A, it's equal to 1 upon ei will remain as it is. Then if I put x is equal to 0, first term becomes 0, then minus 3wl square by 48 will remain as it is, then minus w by 2. Here we have x as 0. If we put x as 0, then we have minus L by 2 whole square, and that becomes L square by 4. So I'll simplify this. Therefore dy by dx at point A is equal to 1 upon ei. Now here we have negative on both the sides. I will take it as common. So minus into the bracket, here this 0, this term will go. Here we have 3wl square by 48 plus wl square by 8. So on simplifying again, we have minus 1 upon ei. Now this will be, here I'll take 48 as the denominator. We have 3w L square. Next, after this we have to make this also as 48, so multiplying by 6 in the denominator. Similarly 6 will be multiplied in the numerator, so we have plus 6w L square. So therefore dy by dx at a will be equal to, here we have 3 plus 6, that gives us 9, so minus 9 wl square upon 48 ei. So this is the value of slope at point A. Now similarly we can calculate the slope at point B. So I'll say that therefore calculation of slope at point B, and for that I have to put at x is equal to, at point B the value is x is equal to capital L. So put this in equation number 4. Hence we have in equation 4 dy by dx at B is equal to 1 upon ei will remain as it is. Now instead of x I'll replace it with L, so w by 4 x square will become wl square by 4 minus 3wl square by 48 will remain as it is. Then here we have minus w by 2. Inside the bracket we have x, so it will be replaced by L. So on simplifying, here we have this bracket. If I simplify, this is 2 into L, 2L minus L into 1, that is L, divided by 2 whole square. So it becomes 2L minus L, that is L by 2 whole square, which is L square by 4. So this bracket is L square by 4. Next, 1 upon ei is equal to wl square by 4, I will keep it as it is, minus wl square by 48 as it is, minus this will be wl square by 8. So I'll keep the denominator as 48, that is the LCM here. Next 4, here I have to make it 48, so multiplying by 12, and similarly 12 will be multiplied in the numerator. Next this will remain as it is. 8 to make it 48 multiplied by 6, so similarly 6 will be multiplied in the numerator. Next, therefore dy by dx at point B will be equal to 1 upon ei. Now here we are having 12 minus 3 minus 6, 12 minus 9, that becomes 3. So we have 3wl square upon 48. So therefore dy by dx at point B is equal to 3wl square upon 48 ei. Now after reaching here, next here we have found out the slope at point B. Now in a similar manner we can calculate the deflection. So I'll show the deflection at the center of the beam, because at the supports the deflection is 0. So for the simply supported beam we will find the deflection at the center, which is the maximum deflection. So now I'll say that calculation of maximum deflection, that is at x is equal to L by 2. Now put this value in equation number 5. So your equation 5 gives us the deflection equation. I'll write down y is equal to 1 upon ei will remain as it is because it is constant. Next, w by 12. Now x cube, here x will be replaced by l by 2. So we have l by 2 cube minus 3w l square by 48 into x is l by 2, then minus w by 6, x is l by 2, so l by 2 minus l by 2 whole cube. Now this last term would be cancelled out, l by 2, that is 0, so this term is entirely 0. Here when I am simplifying this, y is equal to 1 upon ei, this bracket, here we have w by 12 into l cube upon 2 cube is 8 minus 3w l cube, l square into l, that is l cube, upon 48 into 2, that becomes 96. Last term is 0, so simply neglected. Therefore y is equal to 1 upon ei wl cube upon 12 into 8, that is 96, minus 3wl cube upon 96. So this will be 96 wl cube minus 3wl cube. So y value will come out to be minus 2 wl cube upon 96 ei. So here we have the value as, after cancellation, y is equal to minus wl cube upon 48 ei, and this deflection which we are getting, that is nothing but maximum deflection. So here I'll say that this is equation A. So therefore from equation number A we get maximum deflection, then your negative sign indicates that deflection is in downward direction. So here in this video we have seen for a simply supported beam how to get the slope and deflection equation and get the values of slope and deflection at various points.